So in this section, 6.1.1, we're going to be talking about special right triangles. And there are two special right triangles that we are going to address. So one is called the 30, 60, 90 degree special right triangles. And the other one is called the 45, 45, 90 degree triangle. So for this first one, what happens if I wanted to know what is the cosine of 60 degrees and I did not have my calculator? Okay, so one of the first things I would do is I would want to build a triangle. So let's build a triangle. So we're going to focus purely on this guy right now. So here is my lovely triangle. Okay, and to the best of our ability, it is a actual right triangle, even though it doesn't look like it is a right triangle at this moment. Okay, so let's put 60 degrees right here, and let's put 30 degrees right there. It does not matter where we put the 60 and the 30, but this is a triangle because the 30, 60 adds up to 90, and 90 plus 90 gives us 180. Okay, so what do I know about cosine? I remember from SOHCAHTOA, right, that cosine is adjacent over hypotenuse, right? So here's my adjacent, and then here is my hypotenuse. And just so we have this, this will also be opposite. Okay, so let's go ahead and make an arbitrary letter for adjacent. We're going to call this side A, and let's call this side B. And for hypotenuse, let's give this an actual number. Let's say that it's 2. Okay, it could be any number that we can think of. Okay, so what would happen if I told you to make this an equilateral triangle? If you recall, an equilateral triangle means that all 3 sides have to be the same, equilateral triangle, and all of the angles also have to be the same. So if they're all 60-degree angles, right, where would we reflect? So hopefully what you realize is that we would reflect over this B line. So again, to the best of my ability, I'm going to pretend that this is going to come down here, and this is going to come here, and that this triangle and this triangle are exactly the same, even though they don't look exactly the same. Let's see if I can redo that just a little bit more. Okay, so notice that this length would be B and the second one would be B. This would also be 60 degrees, and then this would be 30 degrees, which together gives you 60. If this is A, then this side would also be A. And if this is 2, that means that this side would be also 2. What else would you know? So equilateral triangle, all sides have to be the same. So even though it doesn't look like it, this picture, all of this would also be 2. Okay? So based on this information, what can we say? How can I write an equation for A? So we would, scroll down too far. So I could say that A plus A is equal to 2, or that 2A is equal to 2, and that A is equal to 1. So notice that I just found what my A value was. So now I know A is really equal to 1, and I just figured out that the cosine of 60 degrees is 1 over 2. So let's go ahead, let's check our calculator out. And so if I turn my calculator on, I first want to check my mode. I am in degree mode, so that's exciting. And then I'm going to say cosine of 60 degrees. Enter. Notice I get 0.5. Excellent. So what happens if I wanted to find my B value? Well, I know that this is a right triangle, so what I could say is I could say A squared plus B squared is equal to C squared. So my A we now know is 1. I still don't know my B squared, and my C squared is 2, so 2 squared. So 1 plus B squared gives you 4. B squared gives you 3. So B is going to be plus or minus the square root of 3. Now we're talking about length, so we're going to kind of forget about the plus or minus, and we're just going to focus on the positive version of root 3. So now with this one, what happens if I asked you for the sine? So the sine of 60 degrees. We can then say the sine of 60 degrees is opposite over hypotenuse. So this would be a root 3 all over 2. So again, we can kind of now use our trig functions. So let's go ahead and plug this into our calculator. Sine of 60 degrees. Press enter. Oh, we get a gross looking decimal. So let's check to make sure that that decimal is the same one as our other one. So I'm going to say square root. So square root of 3. Scroll out. Divide by 2. Bam. Notice that we got the same answer. So I do know for a fact that the sine of 60 degrees is equal to the root 3 over 2. Okay. Now, I randomly picked this number 2. What happens if I picked a different number, right? So let's come back here and let's try a different one, right? So again, I still want to know cosine of 60 degrees, right? So here is my new triangle. Here it is. So I'm going to say 30, 60. So I'm going to switch it up. So again, I'm going to know my hypotenuse. So I'm going to say that this is A, this is B, and let's pick another number. Let's pick another even number so that way we are making it kind of easy for us. Let's pick 10, right? So let's see what happens when I plug in the number 10. Okay. So again, notice that this is create an equilateral triangle. This time I'm not going to reflect over the B line. I'm going to reflect over the A line still because this is your 30 degrees. So again, if I reflect, it would look something like this. So this would also be 10. And then this would also be B, which means that all of this would be 10. All right. So again, I'd say B plus B is equal to 10. So 2B, or not 2B, that is the question, is equal to 10. So B is equal to 5. So cosine of 60 degrees is still adjacent. So we'd say 5 over 10. And notice, what does 5 over 10 simplify down to? 1/2. Okay, let's double check what our sine was. So let's do 10 squared is equal to 5 squared plus a squared. So 100 is equal to 25 plus a squared. Subtract, we're going to get 75 is equal to a squared. I'm going to take the square root, so I'm going to get plus or minus. And we're only going to deal with the positive version. But we got the pesky radical. So let's go ahead and simplify that radical. So how to get 75 is really the square root of 25 times the square root of 3. So 5 times 3 gives you your A value. So if we come back up, so we know what we're dealing with. So we're dealing with the sine of 60 degrees. We're going to get opposite, so the A, so it would be 5 root 3 over hypotenuse 10. The 5 and the 10 should cancel each other out, leaving you with root 3 over 2. So it actually does not matter which ones we pick. We can get our values all the same. Okay, so we have a generic way that we can write our 40-60 triangles. Or sorry, 30-60 triangles. So 30, 60, 90-degree triangles. So this is our generic way. Let me erase that part right there. So again, we have to know 60, 30. So off of what we kind of started to notice is that your B value was always across from 30 degrees, and it was always half of your hypotenuse, right? So again, half of B is half of 10 was 5. Notice on our very first example, half of 2 was 1. So whatever value I have, let's say that this value is 2x, off of the 30 degrees will just be x, okay? And then off of our 60 degrees, this will always be x root 3. Okay, so no matter what we have for our values. So again, here is our generic 30, 60, 90 formula in order to figure out all of the values. Okay, so the second one is the 45-45 degree triangle. Okay, so if I take a look at a 45 degree triangle, what kind of triangle normally is this? And if you said isosceles, you are correct. So it actually does not matter what our values are. So I know that this will be x, and then this will always be x, or a value, right? So so let's pick an arbitrary number for this guy. So let's say, actually, you know what? Let's come up with our generic one first. So Pythagorean theorem. So we're going to call that question mark for right now. So we would say x squared plus x squared is equal to question mark squared. And then this would be 2x squared is equal to question mark squared. And then I would take the square root of over here. And then 2 can be in its own one. Radical of x squared would be in its own one. And then this would just be question mark. And so the square root of x squared will just be x and a root 2. So x root 2. So this guy we can actually call x root 2. So we're going to use this value to figure out a couple of 45 degree triangles. So let's create another 45 degree triangle. All right, let's test it out. So again, 45, 90. So what happens if I told you what is the sine of 45 degrees? We don't know what that is, right? And I told you that this length was 1. Okay? So I know that if this is 1, this will also have to be 1. So I know that that's 1. This will be 1 squared plus 1 squared is equal to, let's call it x for right now, x squared. So 1 plus 1 gives me 2. X squared. X is equal to plus or minus the radical of 2. Again, we don't have a negative distance, so x is just equal to the radical of 2. So this is just the radical of 2. And if you think about it, 1 times the root 2, which is what we had, 1 times root 2. And so sine of 45 will be opposite, it actually doesn't really matter, 1 over root 2. And if we come to our calculator and we test it out, so sine of 45, we're going to get, again, weird looking decimal, but if I say 1 divided by the radical of 2, I'm going to get the same value. Okay, let's try a different one. Let's try another one. So what happens if I have it looking like this? So this time, of 45, I say that this is 3. So again, this one side doesn't have a radical, but I do know that these have to be even. So let's put x and x here. So again, I want to know the cosine of 45 degrees. So I'm going to say 3 squared plus is equal to x squared plus x squared. So 9 is equal to 2x squared. I'm going to divide both sides by 2. So I'm going to get 9 over 2. And I'm going to take the individual radical of both the top and bottom. So the radical of the fraction 9/2 is the same thing as that. The radical of 9 is just 3 over root 2. So x. And then if I come back over here, I have my value. So if I think about the cosine, so if I go cosine of 45 degrees, it would be adjacent, so 3 root 2 divided by 3, fraction within a fraction, so let's rewrite it like this, right? And then divide by 3, which is the same thing as multiplying by the reciprocal. Notice that the 3's are going to cancel out, leaving you with a 1 over root 2, which, if we plug it into our calculator, cosine of 45 degrees is 1 over root 2. So that's the great thing about these special right triangles, is that you are always going to get the same exact thing. Cosine of 45, no matter what type of triangle we come up with, will always give you 1 over root 2. We can talk about rationalizing in another video of how we can rewrite this so that the radical is no longer in our denominator. But again, we have 45, 45, 90 degree triangle, and we have the 30, 60, 90 triangle.